Uh, I hope everyone is well. In our last class, we're studying different types of energy sources, isn't it, my student? And
Yes, sir.
already I have uploaded the course profile. Your can you see my screen? Can you see my screen, my student?
Yes, sir. Yes.
Yes. Already I am uploaded the course profile, the first lecture PDF slide,
Yes, sir.
the first video lecture, and also today's lecture I have already uploaded in advance. So I request all students to join the Google Classroom. Okay, if I check that how many students have joined, only 7 students have joined, 7 to 8 students. So I request all students to join our Google Classroom as soon as possible. Okay, so let me start. So in the last class, my student, if you remember, we studied a topic called geothermal energy, where we discussed about electricity generation on steam. আমরা লাস্ট ক্লাসে স্টিম দিয়ে কিভাবে ইলেকট্রিসিটি জেনারেট করা হয় ওটা আমরা একটু একটু শুরু করছিলাম, যে জিওথার্মাল এনার্জি ইউজ করে আমরা পানি থেকে কি স্টিম তৈরি করতে। ওকে, সো টুডে উই উইল সি দ্য operation of steam power plant and some parts of the steam power plant. Okay, so the steam power plant is a big topic, so we will continue to take some of the more classes about this topic. So my student, remember, steam power plant is also known as thermal power plant. I will suggest my student to have a notebook so you can take some important notes during this class. So steam power plant is also known as thermal power plant. Okay, so it basically looks like this. It is a schematic diagram or plant diagram where you can see different uh, you know different parts of steam power plant, but the main 4 parts, it has mainly 4 parts. Those are main 4 parts. One is boiler, my student. One is boiler. The second important part is the turbine. The main important part is turbine. The third one is condenser. The third one is condenser, and another one which is missing here, that is the pump. So there are mainly 4 important and major part of steam power plant. Steam power plant এর 4টা major part আছে। একটা হলো boiler, দ্বিতীয়টা হলো steam turbine, থার্ডটা হলো condenser, এবং ফোর্থ হলো ফিড পাম্প বা পাম্প, যেটাতে আমরা কি পানি এক জায়গা থেকে আরেক জায়গায় কি প্রেসার ক্রিয়েট করে নিয়ে যাই। So my student, yeah, as you can see, these 4 parts are mainly operational in this steam power plant. Now the question is that how steam power plant works. Okay, how the steam power plant works. So as I told you that so there are mainly 4 parts. One is boiler, and second one is turbine, third one is the condenser, and the fourth one is the pump. So these are the 4 main important components of steam turbine power plant. So my student, you can see this is a schematic diagram. So this diagram shows only 4 important parts: the boiler, turbine, the condenser, and the pump. And every part has different, operation and different purpose, every part. So if we start with the boiler, you know, so what is boiler? My student, steam power plant is basically named after steam because here steam runs the power plant. Steam power plant বেসিক্যালি তোমার স্টিমের নামে তৈরি করা হয়েছে, কারণ কি এখানে স্টিম দিয়ে টারবাইনটা ঘোরানো হয়, ঠিক আছে? Steam runs the turbine, the steam turbine, so that's why it is named as steam power plant. So to make steam, steam is the gaseous stage. Steam is the gaseous stage of water. So to make steam we need boiler. So in boiler what we do, in boiler we take water and we give heat. Okay, in boiler we take water and we give heat, and after that we make steam from the water. So basically boiler produces steam. Okay, boiler produces steam. So remember, this steam has a very high amount of temperature, very high amount of temperature. The steam has basically two major characteristics. Please take notes. One is high temperature, one is high temperature, another one is high pressure. টেক নোটস, তোমার নোট নাও যে স্টিমের, এই স্টিমের দুইটা মেইন ক্যারেক্টারিস্টিক্স, একটা হলো উচ্চ তাপমাত্রা এবং একটা হলো কি উচ্চ চাপ। দিস স্টিম হ্যাজ টু মেইন characteristics. One is high temperature, another one is, the second one is the high pressure. So this high pressure and high temperature is, come from, the temperature comes from boiler and the pressure comes from pump. Using pump we create pressure. So this temperature and high pressure, okay, this steam is flown to the turbine, is flown to the turbine. Turbine is a rotational device, okay, by the force of hot steam and high pressure is steam, the turbine basically rotates. And how it will rotates, we have a animation video, we will see that how it rotates. So there are so many things connected with the power plant. One is turbine, one is boiler, one other one is pump, and also the condenser. These are the main four parts, but there are so many other things also available in the steam power plant. We will see one by one. So my student, so this high temperature and high pressure steam flows within the turbine, and moves turbine moves. But we all know the turbine shaft, the shaft of the turbine is connected with the rotor, rotor of the generator. So when this turbine moves, the rotor of the generator also moves. In Bengali, a hot fluid এবং হট স্টিম এবং হাই প্রেসারের স্টিম যখন টারবাইনের ভিতরে ফ্লো করে, টারবাইনটা রোটেট করে বা ঘোরে, ঠিক আছে? এবং টারবাইনের মাঝখানে কি একটা শ্যাফট থাকে, একটা দণ্ড থাকে। এই দণ্ডটা আবার কার সাথে কানেক্টেড? রোটরের সাথে কানেক্টেড। সো যখন এই এই শ্যাফটটা বা এই রোটরটা ঘোরে, এটা কাকে নিয়ে ঘোরে? এই জেনারেটরের রোটরকে সাথে নিয়ে ঘোরে। সো কি হয়, পাশাপাশি জেনারেটরও ঘোরে এবং জেনারেটর কি আমার বিদ্যুৎটা উৎপাদন হয়। সো মাই স্টুডেন্ট, অ্যাজ আই এম টেলিং that when this high pressure and high temperature steam flows within the turbine rotates, and it rotates with the rotor of the generator. So we get electricity in the generator. But after turbine, after the steam pressure and temperature becomes less, when it goes out of the turbine, the steam pressure become low pressure. Why? Because we all know the energy cannot be created or destroyed, it can be transferred. So the pressure of steam and the temperature of the steam basically, you know makes the rotational force or converts into the rotational force of turbine. In Bengali আমরা জানি কি, স্যার, শক্তি কখনো সৃষ্টি বা ধ্বংস করা যায় না। ওকে, সো যখন এই স্টিমটা এই টারবাইনের ভিতর থেকে ফ্লো করে, তখন এই টারবাইন, এই স্টিমের যে উচ্চ প্রেসার বা উচ্চ চাপ এবং উচ্চ তাপমাত্রা, এটা কি হয়, এটা ওই টারবাইনের ঘূর্ণায়মান শক্তি বা রোটেশনাল শক্তিতে কি পরিবর্তন হয়ে যায়, ঠিক আছে, বা রূপান্তরিত হয়ে যায়। এই কারণে যখন টারবাইন থেকে যে ইটা বের হয়, যে স্টিমটা বা বের হয় বাষ্পটা, সেটা কি এর প্রেসার এবং টেম্পারেচার দুটা কি কমে যায়। Okay, so my student, after coming out steam from the turbine, it becomes low pressure and low temperature. And now the important topic is, now make this steam again water, again water. So if I want to make steam into water, that means we have to condense the steam, the gaseous form to liquid form. So what we do, we use a condenser. In condenser, the steam becomes water. না কন্ডেন্সার কি হয়? কন্ডেন্সার মানে কি, ফ্রিজে যেমন কন্ডেন্সার কি হয়, তোমার হিট বের হয়ে যায়, হিট বের হয়ে গিয়ে তরল পদার্থ কি বরফে পরিণত হয়, বা গ্যাসিয়াস পদার্থ কি হবে, ঠিক আছে, গ্যাসিয়াস পদার্থ লিকুইডে পরিণত হবে। So in condenser, the steam becomes water. After that, this water is again transferred from condenser to boiler using a pump. We all know that, sir, pump. We use pump to transfer one thing to another by creating pressure. So this pump basically transfer this water from condenser to boiler again by creating pressure. So that's how the total cycle completes. So this is the steam power plant operation, that how it works of the major four component. Always remember, there are four major components. Boiler, there are different types of boiler, we will discuss later. Turbine, there might be multi-stage turbine, that means there might be one stage or two stage or even three stage turbine. Condenser and pump, these four are the main major component of steam power plant. Have you understood, my student?
Yes, sir.
Yes.
Okay,
Yes, sir.
now my student, I will show you a
Yes,
animation
sir.
video, that what I have told to all of you, you just see, so that knowledge will be much more long lasting. Okay, let me show the video first and discuss within the video. Okay. Okay, then we will come back to the slide one more time in Bengali. আমরা একটু একটা ভিডিওর সাথে একটা একটা অ্যানিমেশন ভিডিও দেখব। সো এদের দেখে আমরা আমাদের যে ব্যাখ্যাটা আমরা করলাম সেটা আমরা একটু মিলিয়ে নেব, ঠিক আছে? তাহলে আমাদের কি হবে, তাহলে আমাদের যেটা আমরা জানলাম সেটা আমাদের লং লাস্টিং হবে। ওকে, আমি অলরেডি একটা ভিডিও, এই ভিডিওটা আমি I have already given this video into your Google Classroom. So please, you can share, you can watch this video later after the class also. Okay, so my student, as you see that the steam power plant is also, I already told you, also known as thermal power plant, because it uses the heat, it uses the heat of different types of um, you know uh, different types of fuel. So that's why it is also known as thermal power plant. You see that, first of all, this is you can see this is an animation video of steam power plant, where you can see the total uh, you know plant, and it when you see the video, it has a great audio, so you can understand. So this, they have shown different parts, and I'm explaining which part is, you know which one. Always remember, I told you, this is the generator part, this is the generator part, and we all know that we use generator to you know we use generator to produce the electricity. So it is the rotor, you can see the rotor is moving. Okay, so rotor is moving, and it will be connected with the shaft of the turbine. You see that this is the turbine part, this is the turbine part, my student. You can see that the rotor is connected here. If I draw, the rotor is connected here with the turbine shaft. So the shaft, that means the main straight This is the common shaft. So if the turbine rotates, the generator will also rotate, or when that means the rotor will also rotate, and we get the electricity in the generator part. Am I clear? This is the common shaft. So the when the turbine rotates, it is the prime mover. Always remember, the way whatever thing we use to make rotation of rotor, it is prime mover. Rotor কে আমরা যা দিয়ে ঘুরাই সেটা হলো prime mover. So turbine is the prime mover of a generator. Okay, so this is the combined shaft. Okay, let's continue the video. You see that this generator is this is the turbine section, my student. This is the turbine section. You can see the two line. One is high P and another one is high T. P means pressure and T means temperature. So high pressure, high temperature. I told you there are the two main characteristics of the steam. One is high pressure, another one is high temperature. So if I continue the video, you can see the high pressure and high temperature steam is moving, is flowing to the turbine. Okay, so this basically moves the turbine section. So this is the blade of any turbine. We will discuss different types of turbine in upcoming classes. We will have a dedicated class on turbine, so we'll discuss on turbine also. So on that class we will describe detail. Okay, here there are three stage turbine. This is the smaller one is the high. This one is the high pressure turbine, high pressure stage. This is the intermediate stage, and this one is the low pressure stage turbine. Okay, so in this category they have three in this power plant they have three types of turbine, and everyone is moving. Okay, this is high pressure turbine. Next one is the intermediate pressure turbine, and third one is the low pressure. LP means low pressure turbine. So in this three, all this turbine basically connected with the generator. So this when this turbine moves, okay, you can see the value is given. Suppose the pressure might be 170 bar, a huge pressure, and temperature is 353 degree Celsius, my student. So in basically the turbine moves when the high pressure turbine, and we get you know so the next thing is the compressor, the condenser. Okay, so you can see that just after the turbine, this is the condenser stage. Here we flow the steam and we get the water. We flow the steam. You see that in this video. This is the condenser stage. Here the cold water is flowing. Is the cold water is flowing. So when the steam comes with the cold water, it becomes water. In Bengali, যখন এই বাতাস তোমার এই বাষ্পটা যখন এই ঠান্ডা পানির সংস্পর্শে আসে, তখন কি করে, তার ভেতরে যে তাপটা আছে সে ছেড়ে দিয়ে কি ওই স্টিমটা তখন কি হয়ে যায়, পানি হয়ে যায়। ঠিক আছে, এবং যেই পানিটা আমরা ব্যবহার করতেছি ঠান্ডা পানি, সেটা তখন কি হালকা গরম পানি হয়ে যায়। ঠিক আছে, এইভাবে কন্ডেন্সারের মাধ্যমে কি দেখবে ফ্রিজের পাশ থেকে কিন্তু গরম বাতাস বের হয়, ফ্রিজের পিছে থেকে দেখবে কি হট গ্যাস মানে তাপ বের হচ্ছে, কারণ কি সে ভেতর থেকে তাপটাকে কি বাহির করে দিচ্ছে। So in this condenser you can see the steam is flowing and also the cold water is flowing. Okay, so condenser, in this condenser the steam becomes water. Finally this water is is using, this is a pump. You can see the feed water pump, because it transfer waters from condenser to boiler. So it creates high pressure. It takes the water at low pressure, but it creates high pressure. You see, high pressure. It takes low pressure water and it creates high pressure. And as I already told you, the pressure of steam basically is created by the pump. So it creates high pressure and it moves, the water moves to the boiler. Okay, so this is already we saw three part. One is turbine, we saw another one is the generator, we saw the condenser, we saw the pump, we saw. But the fourth stage is mainly the boiler, where the steam. This is water tube boiler. What is water tube boiler we will discuss later, just after this video. So in this boiler, basically, at the bottom, the fuel is burning. It can be coal, it can be natural gas. Okay, so in Bengali যে একেবারে নিচের দিকে, বয়লারের নিচের দিকে কি হয়, ফুয়েল পোড়ানো হয় বা জ্বালানি পোড়ানো হয়। এটা হতে পারে কয়লা, হতে পারে এটা হতে পারে গ্যাস, হতে পারে। পোড়ানোর মাধ্যমে কি করে, যে হট গ্যাস তৈরি করে, বাইরের থেকে বাতাসকে নিয়ে সেটাকে হট গ্যাসে তৈরি করে। ঠিক আছে, ওই হট গ্যাসটাই পরবর্তীতে আমার স্টিম তৈরি করে। সো we can see that the burning of the fuel here, the fuel might be coal, or the fuel might be natural gas. Okay, so basically they take normal air from the outside and they burn it, they burn the air, the normal air, they burn it, and they make hot flue gas by burning. So the temperature of that air becomes so much, and this hot flue gas is basically used to make steam from water. You see, so this is the hot flue gas. You can see this is the hot flue gas. Economizer is a different part, is a separate part. We will discuss in the next class. Economizer is the extra part. So you can see that the burning of the fuel creates hot gas. Hot gas, this is the hot gas. So when the water will flow, you can see when the water will flow inside from the hot gas, it will take the heat, and my student, we will get the steam. So the red line basically is the steam, high pressure and high temperature steam. So the video is a too long video, so I have already given to you. So I request to you that you see the video properly in home. So after that, we continue our our slide again. That there are some uh, line here available here. You can see that that steam engine is an external combustion engine. Why? Because the burning of the fuel happens outside of the turbine. That's why it is known as external combustion. Combustion means burning of the fuel. যেহেতু দেখবা যে এই ফুয়েলটা কয়লা বা গ্যাস, এটা যেহেতু টারবাইনের বা ইঞ্জিনের বাইরে পোড়া হচ্ছে, এই কারণে এটার নাম হচ্ছে এক্সটার্নাল। এক্সটার্নাল মানে বাহিরে, এক্সটার্নাল কম্বাসন ইঞ্জিন। And another line is given here. You see that the main working substance is steam. That means the main working element is steam, which is used to rotate the turbine shaft. Okay, the steam is basically used to rotate the turbine shaft. মেইনলি স্টিমটা হলো কি টারবাইনকে ঘোরানোর জন্য বেসিক্যালি ব্যবহার করা হচ্ছে। ওকে, দ্য ফোর মেইন এসেনশিয়াল পার্ট টু generate the power, that is, one is boiler, the turbine, the condenser, and the pump. I already told you. Okay, and generator is coupled with the turbine shaft, which is producing electricity, and generator is used basically to convert the mechanical energy into electrical energy. We all know this, that generator basically takes the mechanical energy and gives us the electrical energy. So that's how the steam power plant works. Now I will ask my student, do you have any question regarding this? I have tried to show you the video so that you can relate my explanation also. তোমাদের কারো কি কোনো প্রশ্ন আছে কি? Do you have any question?
Sir, first line.
First line means
First point, sir.
that steam engine is an external combustion engine. Yes, is it?
Yes.
External, what does external means? External means it happens outside, and combustion means burning of the fuel, the burning of coal or gas. You see that the burning of the fuel happens outside the boiler, but the main engine is the steam turbine. There are some engine where the burning of the fuel happens inside the engine. That is, one is petrol engine, a diesel engine. This engine, the burning of the fuel burns inside the engine. Those are known as internal combustion engine. But here you can see the burning of the fuel happens outside the engine, you know, after just, down of the under the boiler. That's why it is known as external combustion engine. Combustion means burning of the fuel, okay, and external means outside. That's why it is known as external combustion engine. Is it clear now?
Yes, sir. Thanks, sir.
Okay. Anyone have any question, my student? Jahidul?
Yes, sir.
uh
We have question.
yes, please.
Sir, in the first figure, sir.
Yes, in the first figure.
Yes, sir.
Okay. Yes, this
Yes, sir.
one.
This one. Sir,
Yes.
skip one line, sir, for this next figure, sir. Not this one,
Next,
for the here. Yes, sir.
the second figure. Okay.
Yes. Sir, in here, sir, there's a four type of in here. Sir,
Hmm.
can we remove for the pump, and then we'll make a normal connection from the condenser to boiler?
No,
So,
no,
sir,
no,
can we save
no.
some space or electricity?
No. You have to use pump, because pump is, I said, already said that these four are the main components. It does not mean that it does not have other components. It has so many components. We'll discuss some in the next class, but these four are the main pillars. Okay, the boiler, the turbine, the condenser, and the pump. In a building, if you break one pillar from the one corner, it cannot stand. So on that contrary, these four are the main four pillars, so you cannot remove. Am I
Oh,
clear?
okay, sir.
Yeah.
Yes, sir.
Sir,
Sir, in the upcoming classes, sir, can we study for some calculation how much water we needed, how much steam will be making to steam for the turbine, something like this, sir. Upcoming classes.
So what you are talking about, that, sir, how much water is
Yes, sir.
required, how much?
Can we take?
Yeah.
Yes, sir.
Interesting thing is that there is no standardization. If I can clear you, there is no standardization. It is, the power plant is in the generation section. Okay, so the generation section does not have that standardization that it should be like this, the value should be at like this. But we will see some of the you know calculations, some of the calculations definitely we will have. But as you have already studied the power transmission and distribution, isn't
Yes,
it?
sir. Yes, sir.
Those distribution and transmission has standardization. Do you know the what is the transmission voltage?
Yes,
Transmission
sir.
voltage, do you know?
Yes, sir.
There
We
are
know,
some
sir.
standardization that it is told as national grid. In grid, you cannot change your value. That means in Bangladesh, the frequency is 50 hertz, or even in Asia, the frequency is 50 hertz. That is standard. You cannot change. In USA, the frequency is 60 hertz. You cannot change. In Bangladesh, the transmission voltage are some standard transmission voltage. One is 230 kilovolt, one is 132 kilovolt, another one is 400 kilovolt. It cannot be changed. Either you have to take one of three. But in the generation section, it depends. It depends, and it is also depend on the different capacity. So I cannot, or nobody can tell you that the standard value of what will be the boiler pressure, how much water are required. But it basically depends on the different types of power plant. Okay, different capacity of power plant. So it totally their internal calculations. So we will see some of the calculations regarding steam and regarding boiler. But it's in, we cannot show you that the total calculations that uh, the boiler or turbine or condenser. We can show you that, we will discuss some of the mathematical calculation. I understood your thing, but as the power plant belongs to the generation side, the generation side has very less standard. Am I clear?
Yes, sir. Yes, sir.
Okay. Okay,
Thank you, sir.
thank you. Thank you, my student. Okay, next thing is, we already discussed that what is boiler. The boiler is basically the steam generator. Basically, we get steam from the boiler. Okay, and there are some good characteristics of boiler. Okay, and which student have asked me that question? Who one? Is it Said or who? Shoaib Gedi.
Yes, sir.
Shohaib.
Yes, sir. Right,
Okay,
sir.
Shohaib. Okay, the thing is that you asked, that is, a very critical thing, and also belongs to mechanical engineering. The mechanical engineer basically calculates those things. Okay, and we all know that this subject is the basics mechanical engineering. So we are basically studying the basics. Okay, so
Okay,
even the
sir.
mechanical engineer also, the civil engineer also study our electrical circuit and electronics, but they do not study all the purpose. They study that what is a diode, what is transistor, okay, how basically it works, because they engineering is, always remember, engineering is a you know collaborative subject. So you need to know, because we also know some of the programming also, isn't it? C programming,
Yes,
we
sir.
also know. So in this way, that some of the uh, you are talking about the power plant internal calculation, their water flow, those are totally fluid dynamics. Those have one on every one subject for mechanical engineering, one course. So in this course, it is a totally basic mechanical engineering course, and it is also not required for us. This work is not for electrical engineering. Electrical engineering total belongs on electricity, the power plant section. So those water flow and water, how much water flow will be required, what will be the radius, it is totally depend on the mechanical engineering. Can I make it clear?
Yes, sir. Yes, sir.
Okay, thank you so much. Okay, these are the essentials of a good boiler. That means these are the important characteristics. Okay, you can easily study, and you can easily this thing, that the first one is the produce maximum quantity of steam with the minimum fuel. It is a very you know easy thing, that way the boiler should give us maximum amount of steam with minimum fuel consumption. Okay, this is one of the good boiler capacity. It should be economical to install or should require less attention during operation. It should be economical. When we install a boiler, it should be, it should not take so much cost. And also during operation, when the boiler becomes operative, it requires little attention, that means little maintenance. So that the major thing is that we need not to pay so much money during operation. Okay, in Bengali, যখন বয়লারটা আমরা সেট আপ করবো যাতে এটার খরচটা কম হয়, এবং যখন এটা চলে তখনও যাতে এর অপারেশন সময় যাতে মেইনটেনেন্স কম লাগে, মেইনটেনেন্স যত বেশি মেইনটেনেন্স তত বেশি কি কস্ট. He said that it should rapidly meet the fluctuation of load. Fluctuation means variation. My student, fluctuation means variation. That means in one time the demand is high, another time the demand is low. The one time the demand is high, another time the demand is low. So that is fluctuation of load, and it is very natural in practical life also. In sometimes, suppose in the morning the electricity demand is low, but in the evening the electricity demand might be high. So as the power plant generates electricity, and we generate basically the AC, the alternative current electricity, AC current, which cannot be stored, isn't it, my student? Can we store AC current?
No, sir.
We
No,
cannot
sir.
store. We can store DC.
DC current.
DC electricity we can store, but in AC electricity, suppose in morning the demand is low, but if Suppose the demand is if I compare with the 50 megawatt, suppose the demand is 50 megawatt. The demand is 50 megawatt, but you are producing 100 megawatt in the power plant. But remember, can we store the other 50 megawatt? No, because this is AC. We cannot store. So that's why, my student, at that time we need to, you know, change. We need to make less steam. So, you know, at that time the boiler should produce less steam. But when suppose our demand is 150 megawatt and we are our power plant is producing 100 megawatt, so we have 50 megawatt short. So at that time we need more electricity. So at that time we need more steam in the boiler. So that the thing that a good boiler should rapidly means fastly, very fastly, it should rapidly meet the fluctuation. So when the demand is high, more steam will be, produced rapidly. And when the demand is low, we will stop producing less steam, we'll stop producing more steam, and the steam production will be less, and it should be also very rapidly. So it is rapidly. So this is one of the important part. He said that it should be light in weight and also should occupy less space. Yes, that the overall weight of the boiler should be light. That means, less weight, because when the weight becomes so much, it's very hard to handle or even install the whole boiler section. And also should occupy less space, because when you are establishing a power plant, you need to also manage the space. That means your land. You might have in Bangladesh, suppose, a highly populated, densely populated country. So here land is also a problem. So we cannot make a big amount of boiler which can take so much land. Even the steam power plant takes a big amount of land, but still it a good boiler cannot take so much of land. So these are the, essentials, means good characteristics of a boiler, or a good boiler characteristics. Always remember. So the next thing is or the probably the last topic is that classification of boiler. Basically we have two types of boiler, my student. One is water tube boiler, another one is fire tube boiler. Okay, so water tube boiler and fire tube boiler. So we can classify the two types of boiler from the name. One is water tube boiler. That means water inside the tube, and hot gas outside the tube. And fire tube boiler, that means fire inside the tube. It is not possible to fire inside the tube. Basically hot gas inside the tube and water outside the tube. That is fire tube boiler. You say that in the water tube boiler, water flows through the tube. That means inside the tube the water flows, and the fire flows outside the tube. That means hot gas flow outside the tube. But in the fire tube boiler, fire flows through the tube. That means hot gas inside the tube and water flows outside the tube. In Bengali, যে দুই ধরনের যে ক্লাসিফিকেশন আছে বয়লারে, একটা হলো ওয়াটার টিউব বয়লার, একটা ফায়ার টিউব বয়লার। তো তোমরা এটা নাম থেকে বুঝতে পারবা যে ওয়াটার টিউব বয়লার মানে হলো টিউবের ভিতর দিয়ে হলো পানি ফ্লো করে, এবং এর চারপাশে হলো হট গ্যাস থাকে। সো ওইখান থেকে ওই হট গ্যাস থেকে তাপ নিয়ে কি টিউবের ভিতরে কি পানি বাষ্পে পরিণত হয়। আর ফায়ার টিউব বয়লার কি হয় স্যার? ফায়ার টিউব বয়লার যেটা হয় স্যার, হট গ্যাস থাকে টিউবের ভিতরে আর চারপাশে কি পানি থাকে। সো ওই ভেতরের যে তোমার থেকে হট গ্যাস থেকে কি হিট নিয়ে পানি কি হয় স্টিমে পরিণত হয়। So my student, there are two types of boiler already we discussed, water tube and fire tube. So let's see the difference between the water tube and fire tube. So as we already told you, you can see from the figure also, this is water tube boiler. You can see that this is the burning. I showed you in the video also. This is the burning. Here the fuel is burned, the air is taken and the fuel is burned. So this air becomes hot gas, and the total chamber, inside the total chamber the total, it is filled with gas, and inside the tube you can see the water. The inside the tube, it is water. So that's why it is known as water tube boiler. And in fire tube, you can see that inside the tube the hot gas, and there is a water chamber. So inside the tube there is hot gas, and the hot gas flows, and from here steam is generated. And as we know that steam is light in weight, বাষ্প কিন্তু হালকা, পানি থেকে হালকা. So the steam goes upside and we can take steam from here. Even here also the steam is light in weight. So that's why you go. So this is water tube boiler. This is fire tube boiler. My student, remember the water tube boiler is basically used for large power plant. That means when you have when you need large amount of steam, it is required water tube boiler, because you see that the amount of hot gas is much more here and the amount of hot gas available is much less here. So it is for large power plant, and the fire tube boiler is for medium or small power plant. And also you can see here, my student, that the steam generation will be much more higher in the water tube because there are so much hot gas. So the generation rate is also higher. But on the other hand, the generation rate is, a little bit less than the water tube boiler. But interestingly, the efficiency is also higher in the fire tube boiler. Sorry, the water tube boiler, the efficiency is also high. The efficiency is a little bit low in the fire tube boiler. So let's see the differentiation chart where it is, given. So in the water tube boiler, you see that the water inside the tube, and the fire tube boiler, the hot flue gases inside the tube. The it generates steam at a high pressure. In the water tube boiler, the steam pressure is very high, and in fire tube boiler, the steam pressure is very low. If these values are standard value 165 pressure bar or even 24.5 bar, steam generation rate is higher, as I told you, that as the hot gas is much more, so steam generation rate is higher and steam generation rate is lower. The overall efficiency is high in water tube, the overall efficiency is low in water tube. The operating cost is high because the water tube boiler has so much hot flue gas in the whole chamber. That's why the operating cost is high and operating cost is low, because it is also used for large power plant, and the fire tube boiler is used for small or medium power plant. Bursting chance, that means risk factor, is much more here in the water tube boiler, but the risk factor a little bit less in the fire tube boiler. And last but not the least, we already told that the water tube boiler is used for the large power plant, and the fire tube boiler